Todd Owens again, and welcome to this edition of I.O. Matters. In this session, I want to talk about Fibre Channel and in general storage networking and the futures. Where is all of this going? So we have servers connected to shared storage over storage area networks. And today, in the Fibre Channel world, we're sitting at about 16 gig Fibre Channel connectivity. In the Ethernet space, or what we call iSCSI, the majority of connectivity is done at 10 gigabit Ethernet, okay? And these are great for today, but where are we going in the next 2 or 3 years? Well, there's a lot of things that are changing. The easy one is speed. So 16 gig, today there's available 32 gig FC, and with iSCSI, we can do 25 gigabit Ethernet for iSCSI. 32 gig is going to be transitioning to 64 gigabit FC and 128 gig FC in the very near future. In fact, we have today a 32 gig adapter at HPE called an SN1610Q that's actually based on a 64 gig ASIC. It will actually run at 64 gig today. The problem is there's no 64 gig switches to connect it to. So it's neutered down to be a 32 gig, what they call enhanced adapter. So 64 gig is a reality. 128 gig is just 4 lanes of 32 gig using a QSFP connection. So these are reality today for Fibre Channel connectivity. The 25 gig is moving into the 100 gigabit, 200, and in some cases, even 400 gigabit. Now, most of this high performance 100 gig, 200 gig is today networking. We really don't have iSCSI running on a 100 gig network or 200 gig network today, but that's going to change. And it's going to change by taking the SCSI out of both Fibre Channel and iSCSI. Now, what do I mean? If you drill down on both those protocols, you'll find out that the native language that the storage devices are speaking is SCSI, Small Computer System Interface. That's been around for 30 years. Heck, at HP, when I started way back when, we used to use SCSI to connect scanners to PCs, right? So everything from storage devices to scanners to printers, all kinds of devices were used for SCSI. Well, today there's a new language, and it's called NVMe. We know that there's NVMe drives out there. They talk a very specific language that's optimized for memory-based storage. So we're talking to memory devices as if they were a disk drive, right? So no more of the rotating disk and seek and rewind and all those other great commands. All we have are memory-based commands. In fact, NVMe only has 13 commands in its entire book of language. All right? What that means is it's much more efficient, and because it's talking to memory devices, it's much faster. So latency becomes a big deal in the NVMe space. So now how do we get those NVMe commands out of the computer and over the network? Well, that's where Fibre Channel and Ethernet come into play. So as we go with NVMe, we're going to end up with a protocol that we call FC NVMe. So this is Fibre Channel networks running NVMe commands over the network. On the Ethernet side, because this is low latency, the first iterations that we're going to see for the next generation storage networks running NVMe over Ethernet are going to be, well, what the industry calls it is NVMe over fabrics. And the first one of these is going to be NVMe over Rocky. And Rocky is RDMA over converged Ethernet. Why is RDMA required? It's to keep that Ethernet connection low latency. So this is available today. There are actually some storage manufacturers who sell disk arrays today that can run NVMe over Rocky. There are also some that do NVMe over Fibre Channel. The big difference here is today's 16 gig and 32 gig adapters and switches will actually run FCNVMe today. The drivers are there, everything's there. We're just waiting for the array to come into being. We need the array to be native FC NVMe. On the Ethernet side, HPE has a plethora of 10 and 25 gig adapters that are RDMA enabled that can run RoCE RDMA, and the majority of those are NVMe over RoCE enabled today. Again, the drivers are part of the driver stack for the different operating systems. Now, primarily operating system that supports both of these today is Linux. VMware is very soon to be supporting both of these, and then Windows will be somewhere down the future. So that's another thing in the ecosystem we're waiting for, is the operating systems. From a security and resiliency standpoint, the Fibre Channel is a dedicated protocol, dedicated network. It's very secure. It's very hard to break into. Understand that NVMe over Ethernet fabrics are running on Ethernet networks with MAC addresses and IP addresses. And, there's some security that has to be, or some safeguards that have to be taken from a security standpoint on NVMe over RoCE. Now, there's one other NVMe protocol that's going to be fairly prevalent very soon. It's called NVMe over TCP, okay? Now, NVMe over TCP is running NVMe commands over a standard TCP IP network. No more do I need the RDMA. For those of you that have been around storage for a long time, this is starting to look very familiar. If we roll the clock back about 5 years ago, storage pundits were talking Fibre Channel, iSCSI, which runs over TCP, and then this thing called FCOE, which was Fibre Channel over Converged Ethernet. Well, this NVMe over RDMA or over RoCE is that same Converged Ethernet. So effectively, we have Fibre Channel, we have Fibre Channel, we have FCOE, and we have iSCSI. And we all know where FCOE went. Basically nowhere in a rack and tower environment. We still have FCOE in things like Synergy where we have contained environments, but when it comes to scalability, this just doesn't fly. So what we're going to see in the future is FC over NVMe on your existing 16 gig or higher Fibre Channel environments, and you're going to see NVMe over TCP on your Ethernet environments. And this essentially becomes a replacement for iSCSI. And just like in iSCSI, you're going to have a choice. You're going to be able to do this with software initiators, or you're going to be able to do this with offload. So if you look at adapters that have TCP IP offload engines in them, they can actually offload the NVMe and do all the work on the adapter and not use any of the CPU or memory resources in the server, and get you darn near the same performance you get with the RDMA-enabled networks that are being proposed today. I think we'll see this kind of technology inside the storage arrays. So within those storage arrays, you're going to have NVMe disks that are talking to RAID controllers or your array controller inside the array. This is the perfect technology to put in there. It's low latency. It's relatively cheap and inexpensive because it's just Ethernet, right? So you're going to see Ethernet silicon switches inside those arrays, talking from the array controller inside the array to the disks actually in the array. But when we get out here into the network, this is really going to be where you see FC NVMe up here, and you're going to see NVMe over TCP in that environment as well. So from a storage networking perspective, these are the kind of things that you need to be thinking about, and you're going to want to future-proof your customer to be able to support these. Even though these don't exist today, as I mentioned, the infrastructure does. So if you're selling Fibre Channel, make sure you're selling 16 and 32 gig Fibre Channel. You're protecting your customer's investment today and enabling them to do NVMe tomorrow. If you're doing Ethernet connectivity and selling new ProLiant Gen 10 or Gen 10 Plus servers, you want to make sure the customer is using 10 or 1025 gig adapters on the latest generation technology that are NVMe over Fabric enabled or ready. Anything that's an RDMA enabled NIC will be in that category. And you want to look for adapters that have some kind of TCP IP offload engine so that you can run this NVMe over TCP at the highest performance. Well, that's it for this session. This is Todd Owens, and I/O Matters.